Hello everybody. Today we are going to find the coordinates of the incenter of triangle ABC, coordinates of whose, if the coordinates of the vertices are given like this, okay, then opposite to angle A, the side opposite to angle A, we have the side small a, similarly opposite to B and opposite to C, okay. The given coordinates are x1, y1, x2, y2, x3, y3. All right? Okay. Now, before we begin, let's look at some results that we are going to use. Okay? All right. If we have a line, let's say PQ, let's say P has coordinates x1, y1, and Q has coordinates x2, y2, and let R be a point somewhere between P and Q. Okay, between P and Q. Let's say somewhere over here. Okay, somewhere over here. Then, if we have PQ by QR to be equal to M over N, okay, M over N, then coordinates of R, coordinates of R will be given by uh, M times x2, okay, M times x2 plus N times x1, N times x1 over M plus N. Similar, the y coordinates will be given by my2, my2, and y1, and y1 all over m plus n. This is section formula for internal division. All right? Okay. We'll be using this result, and we'll also be using a very nice result regarding the proportionality of sides. Oh my god. Damn. All right. If we have a triangle, say A, B, C, and if AA dash is an angular bisector, internal angular bisector, okay, which intersects BC at, let's say, H, then if this is C and if this is B, then BH over HC, BH over HC is equal to BH over C. BH corresponds to C and HC corresponds to B. Okay, so we have BH by HC is equal to C plus B. C over B. Okay, this is another result that we will be using. All right, now let's start. Damn. That's better. Okay. All right. Let I be the incenter of triangle ABC. Incenter of triangle ABC. The incenter will always be inside the triangle. So let's see that be the incenter. Okay. And let's, okay, we will see. This entire side is A. All right, let I be the incenter. Then I will be inside the triangle, and the internal angular bisectors of triangle ABC will pass through I. So if we join AI, then the line AI will be the angular bisector of this angle. Okay, so this is equal to this, and by the property we just discussed, we're gonna have BH over HC, BH over HC is equal to BH over HC is equal to C over B. Okay, C over B. Let's call it equation 1. Now we have this ratio, and using the section formula we discussed earlier, we can find the coordinates of H. Okay, we can find the coordinates of H. Alright, so coordinates of H is equal to B times x2. Okay, B times x2, it is C over B. So B times x2 plus C times x3, C times x3 over B plus C. And similarly, the y coordinates are B times y2 plus C times y3 over B plus C. Okay, all right. Now let's call this 2. Now let's look at this triangle again. Let's look at this triangle again. We have the coordinates of H. Okay, we have the coordinates of H. We have the coordinates of A. So if we know the ratio AI over IH, we can use the section formula again and find the coordinates of I, which is our goal. Okay, which is what we are trying to do. All right, so let's see, if I join CI like this, then since I is the in center, this angle will be equal to this angle, and by the same property which gave us this thing will give us that AI over IH is equal to AI over IH is equal to B over HC. B over HC. All right, B over HC. So it will be very good if we can evaluate HC. And to evaluate HC, let's look at equation 1 once again. All right, let's see, what can we do? BH over HC is equal to C over B, right? So if we add plus 1 like this, then we'll be getting BH plus HC over HC is equal to B plus C over C. All right? Now, BH plus HC is equal to this, is equal to BC over HC. And BC over HC means A over HC. Okay, so C, no, this will be B. Okay, yeah. Now from these two things inside the circular things, we'll be getting HC is equal to AB over B plus C. Okay, AB over B plus C. So taking this value and substituting it right here, we're going to get B as it is. HC was AB over B plus C. So this will be equal to B over AB times B plus C. This B cancels out this B, so B plus C over A. Okay, B plus C over A. So AI over IH is equal to B plus C over A. So this will help us to get the coordinates of I finally. Okay, so finally we have coordinates of I to be equal to A times x1, okay, A times x1 plus B plus C times the x coordinate of H, isn't it? So bx2 plus cx3 over B plus C, all over, okay, all over, we have B plus C plus A. So this is basically A plus B plus C. And similarly, for the y coordinates, we're going to have AY1 plus B plus C times BY2 plus CY3 over B plus C, all over A plus B plus C. All right. And we cancel out this B plus C with this B plus C, which gives us AX1 plus BX2 plus CX3 all over A plus B plus C, comma, AY1 BY2 plus CY3 all over A plus B plus C, okay, A plus B plus C, which are the required coordinates, x coordinates and y coordinates of the incenter I of triangle ABC. Okay, all right, that's what we were supposed to do. That's what we were supposed to find. Okay, the coordinates of incenter I. And one more thing, if you are given the coordinates in 3 dimensions, okay, coordinates in 3 dimensions like this, you can still use the same concept. Okay, this concept, angular bisector BC, then xc by yz is equal to b by c. This concept and the section formula for 3-dimensional coordinates, and we'll get a z component here in the end, which will be equal to az1 plus bz2 plus cz3 all over a plus b plus c. Okay, this will be the required result in 3 dimensions. And finally, in terms of position vectors, we can see that the position vector of incenter OI, I'll just write it in 2 dimensions, okay? I just want to, I'm too lazy for writing 3 coordinates. I'll just do 2. You can, it's basically the same thing, okay? It's basically the same thing. So OI is equal to, what are we going to get? We had AX1 plus BY1 plus, sorry, AX1 plus BX2 plus CX3 over A plus B plus C I, isn't it? If O is the origin and I is the unit vector, standard unit vector along x-axis, and if J is the standard unit vector along y-axis, then we have AY1 plus BY2 plus CY3 over A plus B plus C J vector. Now we can write it as 1 over A plus B plus C times AX1I plus AY1J, okay, AX1I plus AY1J plus BX2I plus BY2J plus CX3I plus CY3J. Okay, we can write it like this. And all right, we take A as a common factor, A as a common factor, A as a common factor, and we have x1i plus y1j to be the position vector of A. So this vector is A times OA. Similarly, this is B times x2 y2 means B, so B times OB vector plus C times x3 y3 means C, so this is C times OC vector. Okay, C times OC vector. So it's basically the position vector of the incenter of this triangle is equal to A OA vector plus B OB vector plus C OC vector all over A plus B plus C. Okay, this is the position vector of OI, and this result will be same even if we take the Z coordinates. We take Z coordinates into consideration. We'll just get something like this, some extra terms like this. Okay, if we have Z coordinates as well, and x1 y1 z1 A, x2 y2 z2 is B, and x3 y3 z3 is C. We'll get the same result for the position vector. Okay, all right, thank you very much.